Like the normal distribution, the log normal is unbounded and often exceeds maximum input values. Therefore, truncation of the log normal distribution is required in many instances. For example, sand grain size is usually log normally distributed and is limited from 60 to 2,000 microns by definition. In our study area, we estimate the most likely size to be 500 microns. Unfortunately, there is no built-in log normal truncation function in Excel, but the formula below will suffice. This formula substitutes for Excel's built-in lognorm_in function, which provides the x values. However, Excel's built-in lognorm_dist can be used to calculate mass density. The truncated log normal distribution maintains the same general shape as the untruncated curve, but values exceeding the min and max inputs are renormalized. We can see this on the PDF chart in the upper left that shows the truncated 3-point distribution relative to the untruncated 3-point LSS and beta curves. The box and whisker plot in the lower left shows that the mean, median, interquartile range are similar, as are the min and max whiskers. We can note that the untruncated 3-point and LSS distributions have outliers reaching beyond the 2,000 micron maximum for sand, designated by the dashed blue line. The truncated 3-point and beta distributions honor the min and max inputs, and I think that either distribution would suffice for any analysis. Now, let's move on to the Excel demonstration. Looking at the Excel spreadsheet, it's very similar to what we saw in exercise 9 on the log normal min most likely max method. So we're using the same grain size example, and when we look at the PDF, the 3-point extends far beyond the 2,000, which was the max value for our grain size. But you can see with the yellow curve, which is our truncated log normal, it truncates at 2,000, doing what we want it to do. When we look over below at the box and whisker plots, if we compare the 3-point, which has outliers beyond the 2,000 limit, we see that the truncated log normal is truncated, that the median is very similar, and the interquartile range is a little smaller than that of the untruncated curve. And also note that the max whisker on the 3-point is a little bit more than that of the truncated distribution. As with our previous video, if we come over to the right, here's where we do our calculations. And here, if we click on the log norm end, we see our formula here, which is quite long. The other thing to note is that I've named the cell addresses, which make these kind of calculations a bit more easy to understand. Also, as with our previous worksheet, I've put the formulas for calculating mu and sigma for the 3-point and the LSS method in the spreadsheet. I suggest downloading the workbook and playing around with it and getting comfortable with this. I'll leave a link for the worksheet in the video description. Thanks for listening, like, and subscribe.